Alright, we're at problem number 17 now. I believe, no, I gotta do 16 first, so let's go over here to 16. Alright, problem number 16, we're adding radicals. Radicals have to be what we call like radicals, which mean they have to have the same radicand. 48, let's simplify that one, is 16 times 3. And the square root of 16 is 4, so that is a 4 root 3. 75 here is a 25 times 3. So if 5 comes out, now remember it's 2 times this radical, so when the 5 comes out it's 2 times that 5. So that's going to be plus a 10, and then we have the 3 is 3, that came from the 75, still left over. And 12 is a 3 times 4, so we take the square root of 4, which is 2, times the 5 is 10 root 3. So now we add up all of our radicals. I've got 4 plus 10, that's 14, plus another 10. I've got 24 root 3's for a total. So that's my simplest answer. Problem number 17 is a FOIL problem. Okay, we've got what we call binomial radical expressions that are being multiplied together. And it's FOIL, but remember FOIL is just an acronym for memorizing what you do when you distribute. So you take 7 times each of these. So we go 7 times 2 is 14. 7 times negative 3 root 3. This is like just a 7 times the negative 3 on the outside. So it gives us negative 21 root 3. So it counted up how many root 3's we had. Next, we're going to distribute 2 root 3 times the 2. So we multiply the 2's. And then 2 root 3 times the negative 3 root 3. When you do that, you take 2 times the negative 3 is negative 6. And then root 3 times the root 3 is root 9. And normally I wouldn't even write root 9, because the square root of 9 is just 3. Root 3 times root 3 is just a 3, no radical. And that's what the square root of 9 is. So we'll clean this up now. This is a 14 minus, here we got like radicals, minus 19 root 3. And this again is negative 6 times the 3, or negative 18. So for negative 18, that's negative 4 minus 19 root 3. Problem number 18. Root 5 can't be simplified. 75 we have seen is already 3 times 25. So we break out the 5 times the 4. So let me give myself just a little more space here to write. So that's root 5 minus, bringing out the 5 from the square root of 25 is minus 20 root 3 plus 2 root 3. Can't be simplified. Now adding up like radicals, we get root 5 minus 18 root 3. And those can't be combined because they're not like radicals. So you just leave them. Okay, this next problem, number 19, we got 4x to the 2/3, and in radical form, we just have to memorize that 3, that denominator in an exponent, means the index of a radical, and the numerator means the power on the x. So that's 4 times the cube root of x squared. And finally, number 20, write this expression in simplest form. Again, it's got a exponent that is a fraction. It's negative 2/3 up there, and that 3 again means take the cube root. Okay, rather than write this thing all with a big old cube root symbol around it, instead of doing that right away, I think I'm going to use the laws of exponents. The law I'm going to use is that when you have a product of things, which we have 27 times the next to the negative 12 raised to an exponent, you can raise each individual thing to that exponent. So it's 27 to the negative 2/3 times x to the negative 12 raised to the negative 2/3. Using laws of exponents again, this 3 means take the cube root of 27, so that's 3 to the negative 2. So I've taken the cube root of 27, that 3 then disappears because I've applied it to the 27. And here I'm going to use the rule that says you multiply exponents when you have a power to a power. So that's x to the 12 times 2 is 24. It'll be positive 24/3. So our final answer is this. We simplify the exponent to an 8, 24 over 3, and we take 3 to the negative 2 to the denominator, making it a positive 2, because that means reciprocal, this negative sign does. So that means put me in the denominator, which we did, and there is our final solution. So that should be problems 16 through 20.